called Vitello, which was photographed by the Lunar Orbiter, unmanned craft, in 1965. This was just one of the photographs it returned. Now, I don't know about you, but it looks like something's moved across the surface of the moon and left a track. And when NASA was asked what these were, they said, oh, that's easy, they're rocks dislodged by moonquakes. Right. This rock is about 75 foot across, given the scale of the photograph, and it has rolled up out of a crater several hundred feet across the surface, leaving a fairly regular type of track. This is a smaller rock, and it's moved further, but it's still come out of a crater. This is what I mean about never a straight answer. You ask a perfectly legitimate question, what are these? You're told they're rocks. And you say, no, I don't think they are. Rocks don't leave tracks like that. And anyway, if those were dislodged, why can't all the other ones be dislodged as well? There are plenty of other rocks around, but none of them were. However, that's almost a sidetrack. They never went back to have a look at those. But this is one of the great achievements of the Apollo program, we're told. Allegedly photographed from Apollo 17 on the way back from the moon. It's the pale blue dot, it's the blue marble, it's the photograph which allegedly fired the environmental movement, because we can suddenly see Earth for what it really is, a really very, very beautiful place. And as you circle the moon, you'll get pictures like this, which of course, equally exciting, Earthrise. Wonderful. But if you say to somebody, yeah, that's a double exposure, and I've actually created a very similar picture myself. I'm not going to show it because it rather spoils the image, but this is a NASA picture from Apollo 8. And you have a look at the details. This is the horizon. Apollo 8 orbited the moon at about 60 miles above the surface, we're told. So a quick bit of trigonometry will tell you how far away the horizon will be. If you're 60 miles above a circular body, how far away is the horizon? And the answer is 250 miles. It doesn't look 250 miles away. Because if it was, would you actually see these relatively small undulations on the horizon, or would it be a completely flat, featureless, curved surface? When you see pictures taken from Earth, oh, by the way, the space shuttle is for real, the International Space Station is for real, anything happening in Earth orbit is for real. So when you see the photographs taken from Earth orbit, and you see Earth, you don't see any bumps on the horizon. All right, it's a bigger place, you're higher up, but 60 miles up, you can see all these bumps. They're quite small. The tallest mountain on the moon, we'll see in a minute, is 15,000 foot high. And they haven't yet been able to identify any of the Apollo craft supposedly left on the moon. So this picture, I contend, is a double exposure. You take a similar one to the one we saw earlier of the Earth and plant it somewhere in there, and it's an impressive picture. Almost like a fantasy. So if you're going to the moon, you want to take a camera with you because you want to take some pictures. So NASA, in their wisdom, chose the most inappropriate camera you could imagine, the Hasselblad. It's inappropriate purely because it's very difficult to use. It's not because it's a bad camera, it's actually a very, very good camera. The lenses are the best around, the camera itself is very good, but it's not appropriate to use under the conditions that we know that it was supposedly used under. There's a lens on the front, obviously. This is a polarizing filter, which is a bit ridiculous because you can only actually use a polarizing filter if you can see through the viewfinder, and there isn't one. There is no viewfinder. It's normally in a Hasselblad on the top of the camera, but because if you're wearing a spacesuit you can't see through the viewfinder, they took it away. You've got an electric motor drive underneath here. This is the shutter button, and this little dial here tells you how many pictures you've taken. Because in space no one can hear you scream, there's no sound. You can't hear the mirror because there wasn't one. So how do you know you've taken a picture? A few years ago, I was interviewed at some American program, and they borrowed the lunar camera replica from Hasselblad. So I grabbed it and photographed it. These are the batteries. They're ordinary D2 batteries. They're made by Varta, in this case. Do you think they might have been affected by temperature? Like cold? Yes. The focus, shutter and aperture rings are controlled by levers, the levers there, and they're operated manually. The only automatic thing here is the electric motor drive, operated from here. There is the counter, the numbers here. The magazines, it's a big magazine here, it holds up to 150 photographs, 150 images, 35 foot of 70mm film. Same film as is used on the IMAX cinema today. So when you're in your spacesuit, this is what you see. There's your exposure meter, 125th if you're in sunlight, and 5.6 at 125th if you're in shadow. I don't know if anybody here has ever used a camera as complicated as this one, but you have to be fairly careful that you get it right, and there's something else you have to do. We'll come on to that in a minute. This is just to identify what a camera looks like when it is photographed at chest level and the same camera photographed at eye level. The point is not so much that the camera itself is very different, but the horizon. I've deliberately used a fence quite close because it gives probably an exaggerated impression of what happens. The point is that the lower the camera position, the lower will be the horizon. It's optics. It doesn't matter whether you're on the moon or the earth, the same thing will happen. But if you've got a high camera position, and I photograph this at eye level, you'll get a high horizon in the background. A low camera position, low horizon. It's important when we start looking at the pictures in a minute. We will be looking at some genuine NASA pictures shortly, but we do need the backstory to get the full impact of what we're actually looking at. This is Neil Armstrong, Buzz Aldrin, in the lunar lander. Now, here's a question. You've probably all heard the famous landing of the Eagle. That was what their lunar lander was called, the landing of the Eagle. And it landed on Tranquility Base. And you heard the commentary as they landed it. The voice you heard was actually Buzz Aldrin's. And what he was doing was reading off number of feet down, number of feet across the ground, because they were coming in at an angle, allegedly. And Neil Armstrong, who was a brilliant pilot, no question of that, a brilliant pilot, was piloting it. And he got the famous 1202 computer warning, which said that the computer was overloaded and it was about to abort the flight, and they overrode it. So he was landing this craft manually. Now, you could hear every word he said. What does that tell you? That they were wearing their spacesuits. Because if they weren't wearing their spacesuits, you wouldn't have heard a word, because there was a 10,000-pound thrust rocket slowing the craft down literally 3 foot behind them. And if you've ever seen a Harrier jump jet land or take off, you'll know it makes a bit of a fuss. But you could hear every word he said. So he's wearing a spacesuit, obviously, in case something went wrong. So if he was wearing his spacesuit, would you be willing to operate these controls? That is the manual control. These are the dials and knobs that he had to operate. Would you, if your life depended on it, operate those dials with armoured gauntlets? Because that's what we're being asked to believe happened. We'll just go back a minute. Down here is a keyboard. It's just got numbers. It's not got letters. It's got 0 to 9 and 4 entry keys. It was a fairly primitive computer, but you still had to enter in codes, and you had to do it with your finger. Would you operate a computer keyboard with heavy-duty gardening gloves? If you made a mistake, that was it. You never came back. I think probably not. So how did we hear If